Stworzę sobie świat zupełnie od nowa. Stworzę go tak, jak mi się spodoba. Kiedy zechcę, obudzę słońce, ruchem ręki rozrzucę gwiazd tysiące. Uwolnię ptaki, uwolnię wiatr. Stworzę sobie świat. Stworzę świat jak dom, miliony okien, jasny każdy kąt, otwarte drzwi, przez które wejdą przyjaciele. Wielu ich było, teraz tak niewiele. Kiedy zechcę, zatrzymam czas. Stworzę sobie świat.
Hello. I hope you like it, the music that we've prepared. One information is that the music was created by one of the Wro.cpp fellows. So I hope you like it. I promise to promote it. I hope that will become a new tradition. Today, together with me is Michał. Michał will present the first presentation. I will be the second, but let's first go through the first slides. I will hide Michał for a while, and I will go through some introductory slides. I hope it will work. So, first good information that it's already 7 years of Wro.cpp. So thank you everybody for contributing to the community. There was plenty of good meetings in the past. I hope we will be able to rejuvenate again the community, as there was really a little of meetings nowadays, but I hope we will fix it. I set a goal for next meetings to have plenty of talks that make you successful as a C++ specialist. And I already shared with you what I think it means. And I draft some topics that I perceive as a good starting point for making everyone efficient C++ specialist. As I believe, as many of us are saying, that C++ is only a tool, and we need to do specific things with that tool to be perceived as a efficient or good C++ person. So I have a feeling that today Michał and I will contribute a little bit to those topics, and I hope to see more topics that will put more presentations into that picture, as I believe everyone will benefit from that. I also ask you to fill out some survey regarding the, what are you confident about specific technologies, what you are interested in. I've got 17 replies so far. Thank you for all of those. They are really, really priceless for me. And for sure, we, like most of us, feel really strong up to C++ 20, let's say. And after that, we feel less confident. And we are interested in changing that because C++ 23, 26 is have highest interest rates, as also the software development topics and system engineering, which is something really, really good from my perspective because I want to focus on those topics. So I hope you will all benefit from those presentations. So I'm looking forward, for next meetings. And if you did not fill out the survey, here's a QR code. Here's the link to the forms. Please go there and fill it out if you didn't do it yet. I wanted to align everything what we will be doing in next meetings exactly to that. And also, as you see, I'm conducting this presentation in English, and I have I ask most of you while you've been registering on the meetup.com, if you prefer to have those presentations in Polish or in English. There was half, 50-50 answers to half of you vote for Polish, half of you vote for English, and most of us was like, that doesn't matter what language will be used. So we had a short discussion with Michał today, and we decided to go with English just because it will be more useful for more people on the YouTube. More people will be able to use it. So I hope we will set this standard for the next meetings to have those presentations in English. I hope you will like it, and I'm looking forward for your comments. And maybe there are some comments already. Okay, hello. Was cool, whatever it is. Oh, music was cool. So so please let me know if English is fine for you. If yes, then perfect. If not, we will be thinking about changing that maybe. But for now, let's stick to it. The agenda for today, I'm doing the introduction now. I hope I will fit into 10 minutes. Michał will present the presentation called "I Write Code Differently Than You," potentially. I hope you will like it. I see it as a very beneficial one. Then we will have some small break. I don't know how long it will be. I guess it will be 5 minutes for some coffee. And then I will present a presentation about starting and stopping, where I will try to explore some entry and exit options in C++. This presentation is inspired by some of the real projects that we are doing in City Auto. And I decided to look for more information regarding that, and to create some kind of presentation that will contribute to the goal of Wro.cpp meetings. I hope you will like it. And of course, we have plenty of social media channels. If you did not sign up for them, please do it. It just make us having more influence and having broader contact to everybody. So if you did not do it, please go there and register yourself, sign up for the information. I've created also a Wro.cpp GitHub.io page. I hope to put there as many information as possible, and also collect all the presentations that we've done so far. So hopefully it will be our repository for good knowledge regarding C++. And of course, this is open source. So if you are willing to contribute, just go there and prepare a pull request for that page, and I will be very happy to merge it to, and you can help me in keeping the community alive. Okay, we have also the Patronite page when you can support us financially. So if you are open to do it, just go there and sign up on contributions. And we have like one platinum patron, Adam Badura, which I promised to promote on every meeting that we have. So I'm fulfilling that promise. So Adam, thanks again for doing so. And okay, now that's it from my side. So I will switch to Michał. Say something to check if I can hear you.
Hello.
I can hear you.
That's
Perfect.
good. That's good.
So I'm bringing your presentation, and I will hide in a second. So Michał, have a good presentation, and I will be in the background, and I will be watching all the comments that you can write on the YouTube. So if you will have any question to Michał, I will be reading those, and if there will be any question, I will just ping it, and Michał will have opportunity to answer that. So, okay, maybe that's it. That's it from my side, and I fit in 10 minutes. So, Michał, the stage is yours, and I will be quiet, but in the background.
Okay.
Have a good presentation.
It's good, Philip, that you mentioned that. If you have any questions, please write it down. I'm open to be interrupted. I very often digress, so it makes my talks more lively and probably out of the subject. But let's get back to the subject, which is today big clickbaited claim that I probably code differently than you do. What's behind that, basically? Well, I've learned pretty recently in terms of my career a few ways of writing code which very differ from what I did through the rest of it. Basically, since like about 2-3 years, I'm become much more confident with what I'm doing. And I gained some new tools which made what I'm doing more efficient, more bug-proof. So I would like to share with you today with that experience, and I think it differs very differs from what I found and what I learned from other places where I was a developer as well. So a few words about me. I'm a big fan of, I've always been a big fan of Solid and Uncle Bob, because this was one of the, when I'm beginning my career, this was one of the, Uncle Bob's book was one of the first things which I got after starting my career, of course. And it was enlightening. And I for a very long time I was, and I kind of still are a big fan of his way of thinking about code, about testing, about being responsible for your work. This includes TDD, unit testing, everything around continuous integration and agile software development. I also have, right now it's taking 50 years of mostly C++, professional career. But of course, I'm doing this even way longer because it includes studies some time before. So I'm a kind of a guy. This is my background, because not because I would like to tell you that this is me, I'm advertising myself. This is important because this is part of my internal dialogue for recent years. How valid is everything I learned, and because re-evaluation things is very often important. So before we go with that, I work for Silly Auto, and we have a short advertisement. So if you have any idea, if you are a C++ Qt developer, let us know by contacting Piotr Surma. You can find also Silly Auto Careers webpage, which link I haven't put here, but this is also valid way to contact us. And after that short advertisement, let me give you 2 credits for 2 things or people. First of all, thank you for Zbyszek, who I'm hoping he's not here today, and I deliberately did not told him that I will talk about things which I learned from him, basically. Because this would be a different show, and I would like this to be my show, not his. Still, he's a great person, and every discussion with him is enlightening. I'm really honest with that. The second thing is, which is very important, and I think you will benefit from, is basically this very old book. Actually, it's almost more than 20 years right now. It's Martin Fowler's Refactoring, which is also a big foundation of what I'm doing right now. And but it's not limited to that, but definitely something that is a base for what we're going to be talking today. So basically, at some point of your career, when you take a look at a code, especially and the worst feeling is when it's yours, is that your code is bad. It doesn't work. It's just not right and not correct or anything. So you basically start to learn things and try to enlighten yourself or do more coding, because when you do some TDD things, you write more code, more tests, more everything to make it better. But in the end, it's just doesn't work as you would wish. So you're trying many different things, like I don't know, so AI tools, which are not major enough right now yet. We're still needed, fortunately. So you're starting to do things for yourself. You're packing different bits from the internet, and yeah, but in the end you misaligned the client requirements. So. And the pyramid of people that do not understanding each other just collapses. So you end up with things that basically the best code is no code. End of story. Thank you very much. No, honestly, this is not the end. I think that there are some better ways to do code than I was learning. That I learned, and then I was making most of my career. And this basically is a kind of workflow. That's how I learned it. So this workflow is not something that you would say is absolutely new thing. Most of the things which I would probably tell you today are things that you already knew. Maybe even you were doing this, but I assume that it's not that common, given my experience. Also, it's like all those things that you knew have to be fit together, but in the right proportion. If you do not do that, then this basically would mean that you're not doing it correctly. It's something like in a company where they use Agile, and they use Agile, but there's a guy who can go at any point of your sprint and ruin everything that you did and tell you to do something else. So this is not Agile. This does not work that efficiently. This doesn't work well. So you have to be sometimes more. You have to forcing things a bit more, let's say. So what are the workflow rules, which I'm following when I do some code changes. So I do small incremental changes, which are safe, which are very, let's say, almost formal. That's how I would call that. So each of these changes should be in a separate commit. This is very important because we are going to learn today a lot of one of the VCS version control systems, which is Git. And basically, but this is just an example. The same workflow could be used any other tool. So I would like to emphasize that. This is language agnostic. This is tool agnostic up to some degree sometimes. I would just say that Git makes it way better and way easier, at least from my perspective. So what is each change? This is also very important. I think some of you might heard the term that commits should be atomic. If there's anyone who did hear that, please let me know. Because I happen to find that many people do not know what does it mean. And I also thought that I knew what is this, but I never used that up to that degree that I'm using it right now. So the question is basically, what is the atomic commit? The atomic change, as we could say that. So first of all, it's a minimal logical code transformation. And the transformation word is transformation part is basically the keyword here, because as you very often when you use a version control system, you think about changes as a history. And to be honest, no one, when dealing with some nasty bug from the past, is not interested in history. He's interested in what kind of logical step you were doing when you were doing this change, what part of the what transformation you wanted to do to your code. So atomic commit is the smallest logical code transformation that you can add, which is obvious and logical. It doesn't mean that it has to have one line, for example. It might, but it might be very huge, and there are plenty of changes, like, I don't know, formatting code. Preparing before doing many things, you have to when you go into a new code base, there's a problem with formatting, so you have a lot of files which needs to be formatted. This might be one logical change which takes a bunch of files. So this is one of example. But also each change should build and pass all the tests. So even if it's very small and passes all the tests, then it's fine. So this is actually intuitive if you think about atomics, I guess. But this is very important for some reasons, which I hope I will show later. So very, very important part is the change description. So usually the commit have some formal rules. There are some. If you take a look at Linux kernel as an example, if you take a look at the Linux kernel, then you would see that it is very strict in terms of how they create those commit messages. And so you should have a subject. The subject should be like 40 characters. Then there should be some things that are there should be some description which has a certain form. For example, the imperative form, I think it was called, or declarative, where you are not describing what you done in the commit, but you're describing what should be done in the commit. So some sort of recipe. Because we are writing code comments, comment descriptions afterwards, very often we think that we should summarize what we did. No, you should create a recipe because you're doing this for a person who will read it in the future. And very important thing, and this is a key thing, describe why the change was made. This is actually one thing which is very funny is that people tend to describe what is inside the patch. Well, the patch is there. The patch is there. You see the changes. So if you take a look at the changes, you will know, or more or less at least. If the code is more complicated, then it requires some description in the best place would be a commit message. But the thing that some person in the future, when that person will try to dig an information, why did you do that change? This is exactly what he will want to find. Why this change was made. Why? This is the most important thing which I very often repeat in my code reviews to my colleagues. Why the change was made. This is the key part, and I cannot emphasize it more. Basically, think about it this way: why I'm doing this. So this is basically an atomic change, but the commit is. Such small commit does not bring very often a lot of value. So basically, what you need to do is probably group them in some form, usually using a higher sense, let's say. So you should not mix things which are unrelated. For example, if your branch is doing something to add a new feature, you should not fix a bug in the same commit. It might be that you need to do that separately, the fixing part, and then only apply your new feature. So this might mean that there are two branches, but branch should also be atomic. Should also contain one change, and if there is a necessity, or there's something that was very often people tend to mix multiple things in their not only commit but also in their patch sets, the branches. You should not put it there. So this is one of the rules that I follow when I do my projects, and also this is what we do in Silly in our project. Second thing which is important is semi-linear history. There's if you have ever created some CI on GitLab, on GitHub, I think Bitbucket also has a feature like this. So every pull request, merge request, etc. Ends up with some form of merging your changes, your set of changes to the main branch. So if you think about it, if your changes are atomic, that is building, compiling, minimal, then what you want to do is to keep those commits, basically, because there's no benefit in squashing them, for example, because you're losing a value and information which might be in there. But this is not enough. Also, what you want to do is to rebase your changes, so put them on top of current dev branch before you merge them. Why is that? Well, because merge commits can contain changes, but shouldn't. It's actually kind of tricky to find out what's inside the merge commit. And merge commit, if it contains any changes, then it means that you basically did not prepare your code properly. Let's see some examples that I have. So we will let me show you example of some repository. I'm not judging the authors. This is just what I found on the internet, and I think that this is something that that is an example. So don't be angry on any people that pay that, because this is very common from what I see. So I'm using an alias for Gitlog. Basically, this is my alias for that, which is pretty awesome. I will share you with it later on. But it basically is a graph with pretty printing. I'm using this and this is a digression. I'm using this for 8 years right now, and it didn't change. Every IDE I was using evolved, and it starts to look differently and work differently, but this looks the same. I love it. So very interesting thing was happening here, because as you can see, those merge requests are merged in very random pattern, basically. It's very hard to find out because what is going on, because some commits go in parallel, basically. There's a merge commit, and very often there are things like, which I found actually amusing, because this is what I was expecting. So commits like this, fix post merge. So there was a merge which actually was not probably from what I was able to check, was not building properly. So it requires another commit to fix it afterwards. This is very common. This is very often, and this is actually absolutely not kind of not atomic changes, not atomic branching, and this is absolutely not semi-linear history. What is, I will give you an example how I'm doing this in my private project. So your history, this is master branch. There are some branches which are rebased on top of it, because I'm working on different things at the same time. And the history, more or less, it's not perfect, unfortunately. I'm doing this on my own, so I'm sometimes lazy, and I sometimes add comments directly to the branch. But if there is a branch which is more than one commit, I'm adding them in a similar. This is exactly the similar fashion here. So you're creating branch. The branch is rebased on your main branch. This was a main branch before, and I'm creating merge commit, which is basically empty. It only contains some information that this is exactly the place where I should or could place some information about what was this branch doing. So this is a commit description for the whole branch, basically, and it should not, because it's rebased. So then this merge commit is a formality, basically, but it splits nicely the commits that were for that branch and from other branches. So as you can see, this is the history here. So what does it mean? This means that you have to rebase a lot, basically, and this is good, because if you do a code review and your change is based on some very old commit, and you're trying to you would merge it afterwards, then you probably would have to apply some fixes in the merge commit, and what was reviewed before is not actual change that was finally put in. There could be bugs, and there are bugs, we could find. My colleague was doing cute private branch check, and he found out multiple problems done and made in merge commits, especially there. So you avoid bugs by using similar linear history, and you're preserving everything that's necessary. So those small, little, tiny changes. So let me get back here, and yeah. So well, let's. Who knows Game of Life? That's the Game of Life. It's a very old mathematical trick and machinery, which have very simple rules. This is a state machine that. Sorry, this is how it's called. It's an algorithm, cellular automata. Yeah, so it's a very, very old example of something. It's not a real game, but you could think about it this way. So what I was when I was preparing for this presentation, I took some very simple code, again from some person random in the internet. So I'm not judging anyone. Definitely, this was some sort of quick project to have fun. So not something we do professionally, probably. So I'm not judging him, but I've decided to take this piece of code because it's understandable, and make some and play with it to show you some examples how to properly do code changes, how to use the workflow which I'm talking about. So let me first show you how the code works, because, like I said, it's a console thing. It's very simple. So it has a large piece of text, as you can see, which describes how the game of life works. I'm assuming that most of us know what is this and how it works. It has two functionalities, because you can enter a number of cells, which is very badly said, that the number of cells that you have to modify to start the game, or you could read this the board from the file. So let me do just the first thing. So you can enter coordinates for the cell, and you can put here two, and you will see that this is a board. On the board, there's something on the place that could be indexed as 2. So it asks us, because we tell it to put 2 numbers. We're going to add another one, let's say to 3. And this is the game. And if you know the rules of games of life, this will very quickly end up with nothing, basically. But let me start it. So this is after, I think, 2 steps. So we have to, unfortunately, we have to kill it. There is no way to exit this. But we can also read the file. There is one predefined file with the board. So let me load it. So this is it. It ends up with something like that. And if we start the iteration, it will evolve a little bit. As you can see, it's pretty fancy, even if it's a very simple piece of code which just writes to the console. And this is the state in which evolution stops, basically. So how does the code look like, which does it? So I made some preparations, and I've cleaned it up a little bit so that we could work on that. But this is basically what we end up with. And as you can see, I don't want you to fully understand everything. I will just point out important parts. This code has 180 lines with a new line at the end. So it's not very complicated. It contains a main function, which does the printing here. It does some loading from file. Here is a loop which basically does that first functionality, which just when you can put it from the keyboard. It prints the grid and does if you start the simulation, it will just forever while. Let's say fine. This is fine. We would like to we would like to have this. It uses few functions. It has few functions declared. Clear screen, which is purely clear screening thing. Print grid, copy grid, determine state. So here is the thing. And as you can imagine, these also are fairly simple things. This is just printing. Copying is done in a bit surprising way, because this is the thing that you are copying to things. So this is I'm not sure. Usually in C, this is the opposite. And determine state. This is something I'm not going to go into detail. I'm not going to even try to understand if this is correct, but it's also fairly simple. I think it's doable. So let me just check and show you one thing that I very quickly found out there's an issue. So if we decide to put 2 points, for example, 1 maybe, then we could put coordinate, which ends up with crash. Of course. No one. So there is no bound checking. And this might be an issue, right? If you think about it, this is crashing the program, right? So what does the developer like me right now, after my experiences, do with such code? First of all, let me check what is going on here with the table, because this is obvious. We have a piece of code here, like I said, which reads the coordinates and sets them to grid 1. Grid 1 is we can find it very quickly, is a Boolean two-dimensional array. So this array is not perfect, definitely, because, yeah, arrays are clunky, they couldn't be resized. This is a cons, so we are fixing things. So we could change this code in the different ways. One of the things that we could do here is wrap this array into something that is bulletproof and does not have the problem of bounds check or bound of buffer overflow, basically. Secondly, this is, if you think about it, this is a kind of an object, basically. There is an object here, because if you take a look at those methods, just the declarations, there's a print grid, which takes a grid, copy grid, which takes the grid, and the grid to which the copy will be made, and some determine state, which is basically recalculating the grid internally, which is, I would say, this sounds like there's a state which we are handling, and these could be a method. So this is okay. So what I would do when I was before I learned some new things, I would just get that code and probably start writing the class and remove that and create a commit, push it to the repository and said it's done, it's working. I was testing it, promise me. But we could do better. And let me show you how. So first of all, this array is not our main problem here. The problem are the bound check. The bound check are done when you have this array or any instance of it. Fortunately, someone named it the same way all around the code, with exception to having a copy named grid2. We are lucky here because we do not have to search for every Boolean two-dimensional array with this size. But so this is going our way here. But when there's a bound check needed, where first of all it's needed when you actually use some variables to access this array. So what we can do, and this is clean, this will be super, let's say, tight. We could start with creating a branch. This is a no-op. We can do git checkout, and we are doing a branch, which is what is our goal? Our goal is to create wrap grid with class. So this is how we will call it. Let's say this is good enough. Very often you would use some sort of tickets, numbers, or etc., depending on your project where you work, or you could leave it just as it here. But so we're of course right now on the branch, on the new branch, which starts from master, and what can we change here? Let's start with writing a new method. Writing a new method or a function is an operation which does not do anything to the code, anything wrong, because you're not using it. You just wrote a method, right? So let's write a very simple method, which I will call, which will return a bool, which will return bool, and get grid value, which will take const bool of grid which is of size of this thing, and I'm not going to write it manually because this is not a good idea. And this is this method declaration. So we will implement it as every good person should in their separately declare it and separately implement it. So this is the place where we could do our bounds check. So if of course, get grid value. This is not enough, of course, because which value? We need some integers, which will tell us which point of the grid we would like to check, right? So this is what I want here. And if x is less than whatever we have here, so this is grid size +1, and y is less than grid size +1, but also if x is more and equal to 0, and the same thing with y. So this is our bounds check, basically. That's as simple as that. If this is true, then we can return grid of x and y. So we almost finished, but there's a problem. What if not? What if we're outside of the bounds? So if you think about it this way, if we are out of bounds here, current code, and we would like to use this function everywhere in the code where there's an access to our grid. So this code would create an undefined behavior. Undefined behavior, not necessarily always, but very often would create a crash, basically. If it's not, then it might create a crash later on. But definitely, it's something that we should at least terminate. So throwing here an exception, which we could do just this way. Stood runtime error, wrong value. Wrong grid coordinates. And we will just, I will use the simplest form possible. Stood to string x plus. I'm aware of any new additions to C++ recently. There's a print, but let's just keep it simple right now. And y. So you can just throw, because otherwise code probably would crash anyway. So we just terminate the program here. This won't change the behavior, or at least not in a way that is, let's say, is a problem. It's actually exposing the problem rather than hiding it. So this bound check, so it's perfectly fine here to just throw an exception. So we have a get grid value. That's very fine. That's very nice. So what should we do now? Well, you would say replace all the places where the get grid value is. But we do not want that, and not necessarily immediately. What we would like to have is to have a commit. Let's first, before we do any commit, let's just check if we have what we needed. So this is very important part. I'm not joking. I'm doing this all the time. Every time I do some changes, I check. I do self-code review, and I'm checking what I'm changing. Is the patch look good? Is the patch does not add some random stuff or things like that? Also, it's very good to check the status of the repository. These are, keep it as a, don't look at this. This is a trash necessarily only for this very simple example. But as you can see, we have only one change, and this change is in this file, so we are fine. So how to, if you're familiar with Git using console, then you probably are familiar with git add -i. This is interactive mode of adding changes. And I'm using this here maybe a little bit, mostly because I'm used to it. I very often use it always, but because you could just write git add gameoflife.cpp, right? But we are learning new stuff here, and it's very good to know interactive mode of git add. So you could select option update either by using U or 2, and then you just select files which you would like to add. This is one, and then you just enter to exit the mode, update mode. Then you can press Q and exit. So this means that when I do this, so if you take a look at status, you see that we have. Sorry for Polish language. I'm a nerd of Polish language in console. This is funny by itself, but don't blame me. But the thing is that this is our stage changes, so we could comment this right away. But I would like to show you one more thing. So we could let's drop this file right now, because when you're used to it, then the operation of git add -i looks like this. And I'm done. And I'm not right now I'm right now doing double check. I'm right now checking diff if it's staged properly. Why is that? Because very often you have something else staged as well, accidentally or whatever, for whatever reason. So I'm sorry, cached, of course. This is what I do. I'm checking if this is the same thing which I was expecting, and this is some kind of checklist in my mind right now. I'm always double check this with git diff cached, and I really think that you should do as well. So this looks fine. There's no error here. What the last thing we should check if this compiles actually. So let's get to this. It runs. As you can see, I'm just compiling to the output file Gameoflife, and I'm running it in the one command, but we're not interested in running it because this code is not used yet. So let's write a commit right now. So first of all is to add, so what's the title? Title is add get grid value function. And right now, this is the important part. Why I'm adding this method. So here is the place to describe it. Actually, you could elaborate. Think about writing a bug if this would be a bug fix. This is the place. This is exactly the place where you should put all the details of what the bug was, what the bug was, why the bug was, how the bug was found, how to reproduce that. This is what we should place here, because this will your future developer. This might be you. This might be someone else. With thank you for all the information that you place this. If the code history and commit history will be upkept correctly. So why we are adding get grid value function? We need to add bounds check for every operation on grid array. What should we do? What's the recipe for that? Add get grid value function, which which does that. I may be over exaggerating a little bit, but this is also the way I would write that in my code when I'm doing anything at my work. Does the bounds check and returns proper grid value. That's it. This is what we need. So let's get back to the code. This is how it looks like right now. We've added one comment. That's it. So okay. So the second thing that you can do with grid is set grid value, right? So this would be a very similar function with one difference. Setting grid value is, first of all, does not return anything. It shouldn't return anything. By the way, I love that get and set differ only by one letter. This is very nice. So we need to provide the value that we are changing. And yeah, let's define the function by adding very similar bounce check. So this would be the same. And if this bounce check is correct, then we are safe to set. And one thing is different, of course. You should not use const because this is a destructive. This is modifying operation. So so grid of x and y, we are safe to assign their value. So in the same thing could be done here. We should just throw. Why? Because modifying the value outside of this array would be a terrible mistake and potential crash. So we also should crash here. There is no exception for that. So that's what we have here. So okay, we declared that. There's no const. So let me check diff. So we've added this function. We haven't used it yet, but it looks good, at least for me. If you see anything, let me know. Maybe I'm doing something wrong. So we can add it. Like I said, it's very, I like the muscle memory when using console. This is basically something that you very quickly get into it. It requires some learning, but yeah, it's nice. So let's check if this is what we have. Let's check what we have staged. We have staged this one, and basically we can git commit with add get set grid value function. We want to add bounce check for operations on grid array. Add value function, which will oh, that's a good idea. That's a very, very nice. Thank you very much for that. You're absolutely right. Okay, let's do it a little bit differently. I will good catch. I will leave it this way because let's say that I haven't anyone behind my back to check me, right? That's, by the way, you need a code review very often, and doing this on your own, especially when you try to talk to other people, is very very important. So I will leave it right now because this will be an interesting example how to use other tools from Git. I was expecting that I would make a mistake. Yes, thank you for catching that. Which will set grid to given value. Okay, this is what we will end up with. And yes, this is a mistake, of course. This should be a return here. So this should be, when I was experimenting with that, I was using else, so this won't happen. But right now I said, maybe else is not needed. Anyways, very funny. Let's now think about that this bug is not existing yet. By the way, one thing that is very interesting is that the smaller your changes are, when you put those changes into review, the more bugs people will find. If you create a huge, humongous patch set, people will just approve after a day because they don't care. This is so huge that no one sane would be able to wrap their head around. What if you create a commit which has 10 lines. They will find every single mistake there. And this is one of the biggest benefits of having small comments. Bugs become obvious, and it's very easy to wrap around your head around certain patches. So make them small. That's it. Okay. So we're forgetting about the bug, and let me try, because right now, if you try to run this code, it compiles. There's nothing wrong with it. It will run. So let me just check. It will run and it will crash because this is still not fixed. But it's not our problem. This is not because of our new code. So right now, let's start to use it. What we could do right now is to start to use get grid value everywhere that we're touching the grid. So if I will search the grid 1, or because searching is better when you know regular expressions, then you could find all the instances, fortunately. And this is actually me telling you things that I knew because I was dealing with this code. But this basically, you can do very similar. You can be similarly productive with that. So we could replace all usages of direct access to the array with our new method, with our new function, get grid value. All we need to do is to just replace all the stuff here. Yeah, this was important. With our function calls. And that's what we're going to do right now. So get grid value here, A and B. That's it. Okay. Where do we have it more? This is not the one. This is the one. This is interesting. So this uses get grid 2, of course, but doesn't matter. It's the same. It's also some sort of array with the same size because it's done this way. And these are setters, but we're not interested yet in setting this. And do we have any usage of it here? This is a setter. This is just passing the value. So this is it. So the question is this change? Will this change work? I'm used non-buggy get grid value, right? So this should basically build, compile, and let's check it. Let's check it with that beautiful function. So it's test board .txt. Yeah, it seems to work. Everything is fine. So let's check the diff. So this is the diff. It basically changes 3 lines. And my question to you is that think about it for yourself. If there would be a bug here, it would be obvious. Am I insane? I don't think so. I don't think that if there would be any bug, if you should just check one line by line. Yeah, the grid 1 AB true. AB is passed right the same way as it was. There was no change here in this part for grid 2, and there's a grid 2 AC BD. That's it. That's it. This should work. This will never fail, I guess. So, and we basically tested it. So we can just add -i get diff. This is the same thing. So we've added those lines which we intended to add. So we can git commit. Add bounds check to grid accesses. I hope it's a correct English. So we want to have access checks for grid bounds checks. Sorry, bounds checks accesses. Use get grid value everywhere where where we accessed grid. Okay, that's fine. Okay, git status. We're clear. This is junk. So let's do the same thing for set grid value. So I will try to speed up a little bit. So let's do it this way. Let me check. Here is get grid value. I'm still having this beautiful regex. I know regular expression. Stand back, please. So here is the here is the access. Here's the setter for the grid value where we want to add check. So what we want to have is replace this with this. That's the change, right? It's very simple. We want to set grid 2 A B with the value that we extracted from this one. And the same thing we will do for other setters. So let me just write this down here. This is this. I will just, like I said, I will just try to do this quicker. This is grid 1 false. This is grid 1 AB false. So we can copy this. This is grid 1 AB true. So we need to set this to true. Unfortunately, this is not the last place where we do that, but grid 1 XY true. So XY and true. And grid 1 again true on XY. So this is fine. This is fine. So this is the end. So let's check the diff. What we've changed. This is the only change. So again, we can double check every single occurrence of what we just did. And it's boring, actually, but it's easy to wrap around your head with this. So the final check would be to just build it and run it. So right now, if I say enter the coordinates and I will put something ridiculous, we'll have a very nice terminate. That's the magic. Oh my goodness. It also terminates the program. But this is the same behavior, right? It just differs in print, which is not a problem, actually. This is actually better, making code better. This is it's not a pure refactoring. This is alternation of a very small alteration of program behavior, but it's better than it was. So these two particular commits were fine. But because we just decided that we will keep the bug here, if I will say 2.2, this will also throw. Exactly. So, oh my goodness, I made a mistake. How can I fix it? So it's very simple, because we know where the problem is. So it would be the fastest bug fixing in the world. And let me just do it differently. We can just return here. The early returns are fine, and these are fine because this ends up with the block of code. I know I was learning some time ago about that DSCRA way of doing functions is better. But it's not good for patches because it makes the more complex code alteration. This is a separate discussion, by the way, but this way we'll fix it. So how can we update this? There are two ways right now. We're here. We have a change here. This is our diff. Like I said, this doesn't work, so we need to right now because this is our fix and this is the change we are testing. So we cannot right now add everything right here, and because this would be two changes. This would be a bug fix and alternation of the behavior, right? So what we should do rather than that, we should take a look at our history, because commits are software transformations. This we are working on this transformation and we made a mistake. We need to fix our previous thing. So what we would need probably is either git I and then select option patch. This is how I used to do this, but sometimes it's not the best way. But let me put it. The faster way is to use git add -p. This is add by editing patches. So if you do this way, we're not interested in this patch right now. This is not what we want to stage. We do not want to stage any of these. What we want to stage is this. So I'm selecting yes. If you check the history, there's basically 3 options that you will use most commonly: yes, no, and edit. Because you can edit this patch manually. Yeah, and this is so powerful. Seriously, I'm using this all the time. So we do not want this one, and we do not want this one. So let's check what is in div stage. This is only this. So what to do with that? In the status, we see that there's a change in game of life, and there are some other changes there. So if I will, so we have split the changes that fix the bug, and changes that we just did for other reasons. If I would use git stash right now, it will mangle both of those things. So I do not want that. I would like to save this because we would like to have these changes added separately. So how to do it the best way? Well, there is a feature which is called fix-up, commit fix-up. So what we can do is we can create a fix-up commit. What is this? It's a commit with a predefined description, which is intended to fix some other commit and squashed with it, basically. So because we are here, we're here. The problem is in a previous commit than our head, and we have also some other changes. Then we do not want to deal with rebasing, etc. right now. We can create a fix-up for this commit. It has automated description, and right now our history will look like this: fix-up, and the description, the title of the commit that it will fix up. I will show you in a minute how to do that. Let's first make our working tree clean, because we still have some changes in game of life, which are those using of those settings. So we would like to add that. So let me first check if this is working. So let me say that I would like to change one thing, and it doesn't crash. The bug is fixed, definitely. Nothing is happening, but the game works. So let's right now let's commit these changes. Status git add, and let's create it. Use add bounce check for when setting changing grid. So we want to have bounce check when changing our grid, and add replace use setters of grid with set grid value. Okay, this is what we did. I can git show shows us the head, so this is exactly what we've put here. So what we have right now, if we that is the history in which we have a commit fix-up. We do not want to have this commit longer than necessary. So I will show you how to apply this commit to this commit fix up with this. So basically, if you do rebase, you must do it in interactive mode. And additionally, we need to select the master branch, and there's an option which is necessary, unless you have it set in the config, which is called auto squash. So if I do it this way, right now you see that this fix-up comment was moved. It was after this comment. By the way, this is Git rebase uses opposite direction of comments because it's a procedure and it needs to be aligned in this way. That's how the world works. I'm sorry that this is the opposite than I was displaying you in the graph, where the newest comment was on top. Right now here it is on the bottom. Sorry, but that's how it works, unfortunately. So we don't need to change anything. It's already placed there. I'm going to save that, and this is fine. If you take a look at the changes, there's no fix-up. And if we take a look at the code, there's our returns. And the Git status is clean. We have only our unnecessary trash. So, okay, we've added a bounce check. This is very nice. And if you take a look at this, then you'll see that basically the only way we are using this grid is by using this. We are manipulating these grids only by using those functions. Because I think I'm already after the time, and I definitely think that this is something like this is the story about all the practices is way too much for an hour. I think I will finish this on this stage. But what we could do, and I will shortly describe you what we could do, is we could declare a class because this is our goal of this branch, right? We could create a class which is called grid, and this class would be basically copy grid is almost identical to copy constructor, right? So this will be a public grid. There will be definitely something like that, and there's some grid default constructor necessary, and we will just so this will cover this method. Determine state would be probably some sort of update, because I hate the name determine state. It doesn't say anything. We just want to update the grid. Maybe a better name would be something like I don't know, so process or something like that, but or Celera automate a step, but it's too long. So this is debatable. But what it will do is, given that there's a private Boolean, let me just copy this here. It will use the grid. We do not need one. I don't know. I have no idea why there is one here, so I won't use it. But it will just use determine state of grid, right? And you could do the same thing with this constructor. It will just use if there will be some to copy grid, it would use copy grid. Copy grid, which would take this is that surprising thing. This would be to copy a grid and our grid. And we'll do the same thing for a grid. Get grid value, set grid value, maybe slightly changing their names. So doing this this way would create a class which is not used yet. Then we would use the methods that we're already using, and only then we would replace that grid class with the instances of the grid array with our class. In this way, you will split the process into very small pieces. Each one of these is a very nice, clean, short reasonable. The human could reason about it very easily, and very quickly it could find bugs. And each change would be very carefully done to not interrupt or not change to the behavior. So, like I said, I would prefer to skip it this way because it would take a bit too long, but you get the picture basically. So let me just show you maybe some Git commands that are worth working, because as you can see, I'm working a lot with history. I'm rewriting it and reset it every time. Very often I've changed the order of things. So conflicts. So this is something that is very important. Like I said, Git stash is I'm using it very often. So you should know what it is doing. I think it's so basic that most of you already know what is this. This is very nice. When you have two branches, and you should create branches as much as you can. Branches save your work for later. Branches are, if you're not sure if you will break anything with your repository, just create a temporary branch, work on temporary branch. And once you finish, you could use git reset hard from your original branch to the temporary branch, then deleting the branch. Git checkout minus is very interesting. It's like cd minus. It switches back to the previously checked out commit or branch. This is I'm using this all the time. Reset hard is setting your current branch to just by forcing it to point to some other place in the code. So this is also very useful here. This one is tricky. I think it would be too much to show you that, but I'm really thinking, because very often you have a situation where you create a commit, but it's actually you later on you would like to split it somehow. So you could do it just by editing and doing some nasty stuff with when rebase with edit, but you could also use reset minus p. This is kind of this does not alter the repository, but it creates a reverse patch in a stage, and the rest of the changes which weren't in that reverse patch will be in div. So this is perfect thing for splitting into two one commit. Again, it's something worth knowing and remembering. So if you messed up anything of this, remember that Git gives you git ref log. So everything I did today, every rebase, every start, it's saved in a commit. And Git keeps those commits so you could just do something with them later on. So you must think about Git like a garbage of patches, which sometimes are temporary, but it just counts if they're 40 days, I think 40 days long, old. And after that time, it just removes them. So you can check if I did some rebase. Yeah, I did some rebase. You can see the old version of the set grid value function. Git show. And as you can see, there's no return here because this commit is still there. It's not destroyed. The Git does that only when doing maintenance or garbage collection, which is done automatically. You do not think about it, and it's, like I said, I think it's 40 days. So what's more? What's more worth knowing, I think. So like I said and described the commit fix up, it just you just put here a comment that you want to fix up and git rebase with auto squash. In order to make your life easier, you can set, you do not have to put it all the time. You can set your git config with rebase auto squash option, and it will be always there. I also place here auto stash, because when you're doing some temporary changes and you would like to rebase something, you very often forget to you very often need to just stash stuff. This does this automatically, and then after rebasing, it unstashes things. I was testing this, and this worked flawlessly. So I recommend using it. I think it's very good. very good thing to have set in your Git config. So one last thing, and this is important when you work with more complex repository or more complex branch. When you have a branch on a branch, you would like to sometimes rebase it somewhere else. Just unbind it and rebase it into, let's say, your master, because your branch, for example, the branch on which you based it, just got merged. So this is rebase onto. It sets the destination branch and the range of commits from to, or this is usually your branch which you want to rebase onto, and this won't take everything that is a difference between your master branch and your branch on the branch. I think this won't take all that subtree. It will take only this part which you put in from to. And the last but not least, very, very important thing is git bisect. Because if you use the comments the way that I showed you, you will have a lot of small comments. So if there will be a bug which we missed, and this is a very nasty bug which passed all the tests, everything that you did in order to make it work. So the bisect is just binary search in a range of patches. You can bisect something. If it crashes, for example, you can automate that with the script. So that searching of a comment which made started that bug would be very quick. What's more important, because you're using very small comments, that bug becomes very quickly obvious. The thing, I think, Philip, you switched. You took my screen right now. Thank you.
Sorry.
No problem. One more thing which I need to say about it is that the importance of code review. So this is very important thing here in this workflow, because you need a psychopath as your code reviewer. I'm a psychopath as well, because you need to be as picky as possible, because there's no such thing that, let's say, you adding spaces in a comment which modifies code. No, this is not a thing, and there are good reasons for that. So it's not only about it being, nasty Nazi. It's about being it's about the cleanness of the code. Because if you have some mangled changes in one commit, this shouldn't pass review without comment that these changes should be split or maybe clean it up in some way. Because you do not have the ability to reason about those changes properly. And this is a source of bugs. So why to do that? I can see a question if I tried Gen AI for code reviews. Right now, I'm on a crusade of fighting with biological machines. Crusade for biological machines being better than AIs of any sort. So I'm not using the Gen AI. But I think that this is a good point, and this is a very good question. So it's a very good question, because I think this, if you have very small comments, this is also something that is not only good for people, but also for any kind of AI. The problem, I think, with C++, with any AI, is that it's super complex language. It's a language which is very bad for AI because it has so many holes and tricks and quirks and stuff that might be not easy to see if you do not have some experience. So what you want to have is the code reviewer which has some knowledge. And I'm not. I think that in the future, languages which are simpler would be better. Would be more replaceable by AI, for at least from code review side. So that's my way of thinking about it. So what I would like to think about what I would like to think about code review is that it's a process of sharing knowledge. So this is the place where we say how we do the coding. We agree how to do the coding. The code review is a process of discussion, meritocratic, etc. And this is a process of two people agreeing on some common grounds on doing something. So it's a very important process. And I like this quote from Monster Inc. Because if I put 38 comments to your 10-liner patch, this doesn't mean that I would like to that I hate you and you should hate your life and go hell. No. If you add a comment to my code review, and not just nasty approve without anything, if you add comments to my review, then it means you care. You care about my code. You care about our code. This is exactly what I would expect from anything. So be skeptical. Be skeptical about everything. Ask questions, and and assume that I'm wrong. This is the most important thing, and that's what I value with in my colleagues when they treat it this way. So I really think this is important. So there are some pros and cons of this process. So pros are, I think, very, very, very obvious. You see, we are putting most emphasis on the production code. So the production code is on our focus all the time. And basically, if you think about it this way, and this is controversial, but I started to think that my unit testing experience is unnecessary, because why to check change, which is trivial, it's very simple, and it's obvious that it works. So I do not need to write tests for a class, which basically is an effect of a very simple and very minor stakes. What's more than that, writing a unit test for a grid class, which I showed you how to write it, would be a waste of time, basically, and waste of effort. And our client won't benefit from it at all. And this is a bit, I know this is a bit controversial. I would gladly discuss about it more. But maybe let's wait for another talk about it. So it forces you to be more careful, because you see, I have some checklist which I do. I add something. I'm very careful about thinking. I'm very often very long time thinking about how to actually implement that change, because this requires some specific translation. Very often those translations are temporary, after which I remove the code which was created temporarily. So I'm really, really careful not to break anything. But this, again, puts more emphasis on the production code, not on the testing infrastructure, which is only for developers. The bisecting thing is something very precious. And we have had quite a few occasions here in our history when there's some bug which slipped out from our production testing, and it was we could find the line after 5 iterations of bisecting thing, exactly the line which caused it, and it became obvious once we see it, but we did not know how it happened. We just had a procedure which reproduced this, and we applied this to various stages of our. This helps us find bugs very quickly. So there are, of course, some drawbacks, and this is not something I would stay silent about, because this requires people with a certain mindset. This is not a YOLO. This is something that requires you to be responsible for your changes. You should be skeptical also, and you should not be scared to say that something is not working. So I would say that this requires some sort of mindset. It's hard to say it in a. You also have to, you see, you also have to be how to say it. You also have to be able to accept that someone has some objections to what you do. Next thing is that you need to know what you want to achieve. This means that it's very hard to do things, to start and to experiment, for example. So experimenting is out of the scope of this workflow. When you're not sure how to do something, you're just outside of this thing. You can help yourself with some branching, some temporary comments, etc. But very often this is not this is adding a burden to something that is very temporary. So you need to be able and be sure. That's why I'm spending quite some time, how to apply seemingly simple change, not to break anything. And it is tedious at first. It requires you to focus on principles, on doing things very, very carefully. So it might be, especially also knowing the Git as a tool is also a thing that requires learning. So it adds a burden of doing those commands which I've showed you. These are definitely not everything I'm using. These are those which I'm using, I think, most often. So thank you very much. The question is are there any questions?
I don't see any questions. So I've shared with you guys the link for a survey. So if you can share the feedback with Michał, I'm encourage you to do so. I will post the link again. So if you will find that there's like 1, 2, 3 simple questions and 1 open question where you can share more details for Michał. The goal is to make the presentation better for the future. So please find a couple of minutes for doing that. And Max proposed 5 minutes break, so I'm happy to do so. So let's meet at 7:40. And in meantime, I will just turn on the music again, just because I can, let's say. Okay, so thank you, Michał.
Thank you very much.
5-minute break. Thank you.
Stworzę sobie świat zupełnie od nowa. Stworzę go tak, jak mi się spodoba. Kiedy zechcę, obudzę słońce, ruchem ręki rozrzucę gwiazd tysiące. Uwolnię ptaki, uwolnię wiatr. Stworzę sobie świat. Stworzę świat jak dom, miliony okien, jasny każdy kąt, otwarte drzwi, przez które wejdą przyjaciele. Wielu ich było, teraz tak niewiele. Kiedy zechcę, zatrzymam czas. Stworzę sobie świat. Stworzę nowy świat dla ciebie mała, taki jaki zawsze ty mieć chciałaś. Nie będą dzielić nas kilometry, nie będzie bólu, co serce rozdziera. Muzyka zawsze będzie grać. Stworzę sobie świat, stworzę świat jak dom, miliony okien, jasny każdy kąt, otwarte drzwi, przez które wejdą przyjaciele. Wielu ich było, teraz tak niewiele. Kiedy zechcę, zatrzymam czas. Stworzy świat jak dom, miliony okien, jasny każdy kąt, otwarte drzwi, przez które wejdą przyjaciele. Wielu ich było, teraz tak niewiele. Kiedy zechcę, zatrzymam czas. Stworzę sobie świat, stworzę sobie świat, stworzę sobie świat.
Okay, welcome back. I hope you get back to the video. Okay, today I'm going to present some topic, maybe some weird one. I guess I will consider it like kind of basic one, but let's see what you will think. It is I'm following my principle, or the principle to eat your own dog food, and if I propose to the community to prepare a presentation regarding some specific topics, I wanted to make my hands dirty first, and I did that presentation. So the goal here is to explore in how many ways we can start execution of our code, and in how many ways we can end it. So let's start from the entry. For sure, everyone knows how to write the Hello World application, right? So it's a kind of pretty easy thing. You can compile it, you can run it, piece of cake. There are at least 3 ways that you can create main of. There are, when you will check the standards, you will see something like that there are 3 options, and one is implementation defined. And one of the examples, which is not standard way of handling those is to provide a third parameter, which is an environment parameters, which will contain environment variables. And the standard way, of course, is using getEnv function, but you will find yourself that it works on your platform and you don't care about the portability. You can use that way as well. So what happens when you start your code, right? If you are using main, what happens then? So let's use some noisy class for that. So noisy class is just class that stores some name, and it prints something in the constructor and prints something in the destructor. That's it, and it provides some indent just to differentiate some levels of logging. That's it. And I will maybe try to make it some bigger. Oh, let's try it here. Yeah. So I'm creating couple of things here. So I'm creating a static field within the static field class. It is initialized here. I'm creating the static global 1, static global 2. I'm creating the static local variable within the function. This noisy variable serves only the purpose of informing that we are getting into the function, that we are leaving it. The same goes here. So main function will just print that we enter to the main and just that we leave. And here we just call the function with the statics just to check what will happen. So yeah, so let's go further and to check what will happen. So first you see, like in first and last line, you see that static noise is initialized and destroyed in the last line. Static global is initialized and destroyed as a second. And you see that it just follows the normal rules of, order of initialization and order of destruction is different. You see that there is like main function here, it's started, and here, like on the 8th line, it leaves. And we have here the static function with the static variable, which is initialized within the function, but it is destroyed after leaving the main function on the 8th line. And this is like the thing that normally happens. But there is more. When you will play with some frameworks, you can see that there is like non-standard extension like common function attributes from GCC, which can make some of your functions behave as a constructor or destructor when you are running your code. I will show a couple of things when it happened, and when you will run it again, you will see that before any other static field is initialized function, which is which has the constructor attribute, is called, and destroy is called not as the last function, but it is called after main before other static methods were called. Why you should bother about those? So if you will play with the Node.js, for example, and you are writing your Node API C++ extension for Node.js, you will be instructed to call NAPI module with some parameters as an end or a line of your plugin, which is translated to NAPI module X something, which is translated to NAPI constructor something, which is translated to exactly that. And here it is, attribute constructor. So you might find yourself using that feature without knowing that, but if you are using Node.js, please be aware, and the C++, please be aware that it is using exactly that feature, so it follows some special rules of order of initialization and the destruction. just be aware of that in case that you find yourself in some troubles within some bugs or errors regarding initialization. We can load our code dynamically, right? And I was surprised when we've been like dealing with one of the projects in Silly Auto that you can load main function. So you can take normal application like that. You can compile it with shared flag just to create lib main SO, and you can write an application that will load it. So you just compile it and run it, and you will get what you've been looking for. And the previous application was just, printing all arguments you're passing, so you get exactly that. So what happens here? We define the signature of the function that we will be loading. We are loading our library with DL open. We are here. We are loading the main symbol from our library handle. We need to cast it with the reinterpret cast to our signature because the DL theme returns void star. And we are running our main, and it requires two arguments, which is the argc and argv, which is the char star type. Unfortunately, this array of arguments have const char star arguments, so that's why you need to cast it with the const cast, but it will be constant nevertheless. And after all, you just close the library and that's it. And how the logs will behave in such environment. So I used the previously defined code for loading, but I put some extended logging mechanism. So yeah, the main function doesn't take any argument, so it will be different signature, but I'm putting some prints for starting and ending of the main. I'm informing that I'm going to load the library. I'm informing that I will load main symbol, and I'm running main, and I'm closing the library by resetting the shared pointer that will call the DL close. Yeah, and this is how it looks. I will just zoom out maybe and zoom in on some. Yeah, better. So you see that the application just started and stopped on the end, so that our main that loads it behaves normally. Then we are loading the library, and what you see now is after you load your SO library, the whole starting initialization took place. So you see that the function with the attribute of constructor attribute was called first as previously, and all the static fields behaves in similar manner, but it happens on this when you are loading the library. You need to remember that. After that, we are loading the main symbol, and nothing happens more about it. And when we are running the main, it behaves exactly as previously, but it doesn't destroy anything after main ends, right? So main on the line 13, main ends, and nothing happening more until I'm closing the library. So now closing the library starts the static destruction of the objects. And that is like main difference. So static initialization starts when you load the library, and static destruction starts when you unload the library. And this is the first difference which you need to be aware of when you are dealing with application that loads the code dynamically. You can also run your code as a separate process. And there is only one standard way of calling some code as a separate process, and this is by calling stud system, which in fact runs something on the operating system shell. And this is not completely portable because you have different shell on the Linux and different on Windows. So it won't, that code won't work on Windows terminal, but this is the only way, which is in the standard, that you can call it. Of course, like stud system doesn't give you any possibility of direct communication, so you can communicate through files or through named sockets or something like that. So you need to handle that as a inter-process communicate, using some inter-process communication mechanism that you cannot do from your code. You need to use something external, but you can do it. Right here, I'm using the test.txt file just to call something with the stud system, and later on read it with input file stream. You can also use some POSIX functions, and there are plenty of them. I just covered here one just to show that you can achieve something similar as with stud system with popen, and just read line by line the same output, avoiding necessity of creating a temporary file. And why to run the code in separate process? For sure, one of the reasons that you might follow that pattern is just for the safety reasons. For sure, running something in separate process when it is a no code or code that might crash will give you this safety mechanism that when it crashes, it won't crash your application. You will know that something goes wrong on the separate process. You can react on that, restart the process, or do something from your code just to ensure that that your application will behave as it should, without necessity, of handling crashes or something like that on your side of the code. You can also run something as a separate thread, and then you need to be aware of some other stuff. So C++11 brings you the keyword which is a thread local, which means that some variable will be independently created in each of the threads that you have. But when you run something like that, what you see here, you will see that I create here global variable with the thread local attribute. I'm running here the task in separate thread, where I'm printing something just to signalize that it's running, and I'm joining the task to ensure that it runs and it joins before destruction. And when you will check in the logs, you will see that there is only information that was printed from the thread, from the print, but there is no information from the thread local global, which is supposed to be created, but it's not, obviously. And it appears that due to optimization, thread local variables are not initialized until they are used. So when you will change the task lambda to print that is using thread local global, you will achieve completely different thing. You will see that when it is run, the thread local global is initialized, the task is printed, and after that it is destroyed. And you need to be aware of that as well, because thread local variables take part into the order of destruction, and if you have that kind of application, you need to be aware of that. And let's do similar thing which we did previously. So let's try to dynamically load that application that use threads. I'm putting here the thing that I'm closing library, and what you will see here is so I missed something here. I missed so initialize. Yeah, I messed my slide because it's supposed to be here with something regarding the thread, which is not. Okay, so it should behave similarly as it was with. Okay, what happened here? Maybe I will explain here. So what we try to do here is we are calling. Okay, I lost for a second, but I get back. So I load the main again, but what I'm doing here is I'm passing the main to the separate thread, and I'm running that. So sorry for mixing the topics, and I'm just joining that. So what you see here is it just behaves normally as it was before, so nothing changed. But the situation is that it might fail somehow. So you might find yourself in a situation that something like that happened, what you see here. So there might be some kind of assertion, and this is the real situation that we have with our project when we run the Qt library in the separate thread. We get something similar like that. And what was the reason for that is somewhere in the code. For example, I put that kind of the code which stores in static initialization the ID of the thread, and later on within some function it's just checking if it's called on proper thread. So the issue here is that thing will be initialized on the function load, which as you can see here will happen here on my main, on one of the threads that I'm running this main, and later on I'm passing the main. So here the ID of the thread will be initialized from my library, and when I'm running that, I'm passing the main to my next thread, so it will run on completely different one, and that will make this ID with stood this thread get ID completely different, and that will make the whole thing crash here, right? So you need to be aware of that situation, that some code runs when the library is loaded, and some will be later on called. With the Qt library, we have somehow maybe a little bit different case, but it's you can simplify it to something like that. So just be aware of that, and all libraries that have some event loops or deal with the rendering something or play with the graphics might have a requirement to be running on the same thread all the time. and that might happen that when you will be dealing with loading that dynamically, it will just cause some failures. And let's take a look on the exit. I was surprised when I've been playing with the exits, how many exits we have. So for sure, everybody is aware that we can just return from main and that's it. And that will leave the function normally as normal. So it will clean up all the automatic storage variables. So it will clean up everything, and just after that calls to the exit with the same argument as you returned in the return statement. And that's it. So that's the one of the cleanest way of ending your application. Second thing is that you could call std_exit. And std_exit runs a couple of cleanups, like it destroys thread local objects. It calls std_exit functions, flushes some C streams like std_out, std_error, cleanups temporary files created but std_temp file, and return control to the host environment. And you need to remember that object with automatic storage duration will not be destroyed. So whenever local variables you have created within your function on std_exit won't be cleaned up. And there are std_exit functions that you can register. And this register function to be called on normal program termination. So whenever you call std_exit or return from the main function with the return, those functions will be called. The same function can be registered multiple times, and exit is thread safe, so you can call the function from several threads. And implementation is guaranteed to support at least 32 functions. And when you will check those, and I just put some at exit here, and I just register 2 handlers, one with 1, one with 2. And between of those, I put another static variable. And I'm doing that just because at exit mess up with static object destruction as well. And as you can see, it is called in the reverse order of registering and initialization of static variables. As you can see here, I'm registering handler 1. I create main static 1 static variable, and later on I'm registering handler 2, and they are destroyed on the reverse order. So first at exit handler 2, then main static 1, and at exit handler 1. So if you will see somewhere within your code, or the code that you are trying to refactor, at exit function somewhere in your code, please be aware that if you change the position of that function, it might impact the order with when those functions will be called within the destruction order of the static variables, which might lead to crash or calling terminate. You might find yourself in situation that one of those functions, which is the static functions, will be using other static variables, and it might happen that they will be using the static object which is already destroyed, which will lead to crash. And if something will throw within that function, it will call just terminate. So just be aware of that. There is also the quick exit thing. And quick exit, it's something like std_exit, but it's doing a quick work, right? It causes the also normal termination, but it's not calling at exit functions. So it's skipping a couple of couple of cleanups. It's not calling static object destructors at all. And you can register at quick exit functions, the similar as at exit functions, which will be called at reverse order of the registration. So similar rules applies. And here you have the proposal which describes why they introduced quick exit. And when I've been looking for some explanation why you might need it, is that there were situations where due to some mutexes or some other resources, you can lead to crashes or lead to some deadlocks. So just to avoid that, the quick exit was introduced, and at quick exit functions were introduced as well to give you some possibility to do some cleanups. And I extend the previous example with at exits. With at quick exit, I put them in similar places. And when I call stud quick exit, now I need to do it explicitly because it won't be called on the return. You will see that everything will go smoothly up to the quick exit thing. And after quick exit, you will just see at quick exit handler 2 and then handler 1. All the at exit handlers or other static variables, destructors won't be called, so it will be quick in a sense that those cleanups will be skipped. And you have stud underscore exit, and that's as well normal program termination, but it will completely skip any of the cleanups. So no calling at exit, no calling at quick exit functions, no calling of the structures or variable with automatic storage duration, of thread local storage duration, of static storage duration. And closing of open resources like files, for example, is implementation defined. So it is just, information, leave this process and let operating system handle that. So you might find yourself in a situation that that you need to close your process and some static variables crash your process during the cleanup, and the operating system getting information that your process crashes and behaves abnormally, and you need to avoid that. And you cannot fix that because you are using third-party library. So you might find yourself in a need to call that function to just exit the process without any of the cleanups. And as you can see here, I just put to my previous example where I registered at exit function, at quick exit function, and some static variables. I'm just calling at exit and it prints nothing, right? It just stops execution. And you have stud terminate. Stud terminate, it's called by the C++ runtime when your program cannot continue by any reason. You can set your own terminate handler by calling set terminate, and the default set terminate handler calls abort, and you can override that by providing your own terminate handler. But you must be aware that stud terminate is called, for example, when your exception is not handled correctly, right? So it is called, so you can do something about it, but it's your final call then. Most probably you cannot return from that in any way, so you will end up with something similar to abort. And there is abort, which just calls abnormal program termination. The structures from the variables are not called because you are aborting, and functions registered with stud at exit at quick exit are also not called. So it's similar to underscore exit, but it is treated as an abnormal termination of the program, and underscore exit, it's normal termination. And you can end up your code by exception. And when you see some code which have some, RII, you expect that that your code is safe when it comes to exceptions. And when you see something like that, that kind of a code, I'm expecting that when the handle will be destroyed, that this final log will be created with some logs with it, right? And I'm calling the gun method, which might throw. And when it throws, I have a termination, but there is no final log file, right? You check that fun was called within the main function, right? And that's it, nothing more happened. And it appears that, of course, if your exception is not handled, it's calling to terminate, which by default calls abort, and this is what we saw there. And that you need at least one try catch somewhere in your code to enable exception handling, and which includes stack unwinding, which in this situation does not happen. That's why shared pointer, the structure was not called at all. It was just called terminate without doing any cleanups. And what to do? Somewhere on your top level code, you need to put try catch, which will resolve that. And you might find yourself in a need that you can say, okay, but still I can put any other function outside of the try catch, and it will lead again to the same results. So you might try, but it is not perceived as a good practice to do something like that. Most of us don't know that syntax at all, but it emphasized that int main is just calling try catch, and that's it. You cannot put anything within the main which will not be covered by try catch. You have been warned that this might be against your coding guidelines, but that syntax is 100% correct. So if you find yourself reading such code somewhere in your code base, you should know what it does, and it is exact equivalent of this code. So I guess that should be it. So just to summarize the entry options. So for sure there is one main, but you can load it dynamically, and you can call it multiple times. But you need to remember that the static initialization will happen only once when you load the library, and after that you can call the main function multiple times, but it will use the same initialized variables that were initialized when you load the library. And static initialization, you need to remember that there is some order of that, and the destruction order is also specified within the standard. There are some non-standard ways to initialize things that are used somewhere, like, for example, Node.js. And thread local variables are only initialized and later on destroyed when you use them, so that you don't pay for what you are not using. you should remember that you can run your code in separate process or thread, whatever works for you. And when it comes to exits, so there is at least 5 ways that you can end your program. You can call additional function on exit by registering them with add exit. You can put there multiple functions, and in special cases, one function can be registered multiple times. You can set handles for the terminate. And please remember about putting try catch if you want to have stack unwinding, not stack unwinding, but stack unwinding. And I think I missed some slides here, but I will maybe try to. I will try to restart my web server here and check. Yeah. So it's supposed to be separate slide, but nevertheless, I will make it separate. So the question is, what you would like to hear about in next slide? Because I pretty much end here. It is much shorter presentation than what Michał presented. And as you might know or not, I'm contributor to CPP Front, and I'm doing couple of experiments there. And I was presenting something on this on the CPPCon last year, and I could do some presentation regarding that. The cool stuff regarding CPP Front is that it's experimenting with the meta functions, which are the frontier of the work that is currently done within the standard committee. I can talk about the concepts, and if like multiple things, I play with it a lot while I'm contributing to the CPP Front. So I think I can do some workshop or presentations just to give you some hints and my lessons learned from using those within the code. And for example, I can do some presentation regarding deducing this and show you how you do the mixins with it, or do some other cool stuff that you might like. So please share what you would like to hear next now, or you can send me information later on. Okay, concepts, get it. So similarly to Michał presentation, I'm sharing with you the forms. If you can share with me the feedback about this presentation, I would love to hear from you if such topic is something that you are interested in, or maybe it's some trivial topics that you can learn by yourself. And of course, if you can share with me like more feedback about what to do better to make future presentation better or well received, I would appreciate that. Okay. Okay, so I will wait a minute just because there is like some delay. And if there will not be more questions, okay. Concepts are really interesting. Thank you for clapping. Okay, guys. So if you will have some more comments or ideas what to do next, or you would like to hear about any topic that will be very helpful in your daily job, on your project, work, whatever, please share that with me. I will try to find a speaker for that topic. We have plenty of good experts in our community. I already have contacts to a couple of next speakers that we will be discussing what we can present in next month. And for sure, I'm planning to do next meetup, Wro.cpp meetup next month, last Wednesday of next month. The same time it is happening now, so at 6 p.m. So yeah, please wait for more information. I hope, or maybe I will say that if your company is interested in having Wro.cpp community in your premises, in the company premises, that will be awesome. Just let me know if there is a chance of having some offline meetings, and I will be happy to contact with anybody from your company to set the details. Okay, it's already late, so thank you guys for joining today's meetup. I hope you like the talks, and I'm looking forward for next meetings and presentation. Thank you again, and have a good night today. Bye.